You can write your student IDs in the chat box now. I'll save it. Just take some time and write your student IDs in the chat box. Now, okay, I was telling, we are, yes. Yes. What do you want to say? What is the basis of P2R? Which particular
Sir,
set? Yes.
Sir, is it x square comma x comma 1?
Acha, give me a 2-degree polynomial. A polynomial. Suppose I'm considering a polynomial like this: ax square plus bx plus c. Okay, I'm considering a polynomial like this. First of all, you tell me whether this polynomial will belong to P2R or not. Will it belong to P2R?
Yes, sir, it will.
It will belong to P2R. Okay, fine. I'm giving you a polynomial like this: dx plus e. Will it belong to P2R?
Yes, sir.
It will belong to P2R. Its degree is 1. I am giving you a polynomial like f. It will belong to P2R?
Yes, sir.
It will belong to P2R. P2R. Now you see, if I talk about f, then can I express f as some linear combination of x squared, x, and 1?
Yes, sir.
How? What will I write?
I said the same thing.
Yeah, you said the
Zero.
same. I'm just justifying the point that you have made just now. 0 into x
The answer is
square.
correct.
Yes, answer is correct. 0 into x square, 0 into x plus f into 1. Dx plus e can be written as, this dx plus e can be written as 0 into x square plus d into x plus e into 1. Now you see that for every case, we can express the polynomials present in P2R as linear combination of these elements, 1x, x square. And you can quite easily show that this particular set, 1x, x squared, is linear independent. You just take 3 scalars, take their linear combination, equate them to 0, and show that the individual scalars are 0. So this is the basis of P2R. Now we want to find the range of t for this transformation. The transformation was given as t of fx is equal to f of 1 minus f2. This is the first element of the matrix on the right hand side. Second element of the matrix is 0. Then this element is 0, and this is f of 0. Okay, so this is how the transformation is given. If you carefully observe that the theorem that we discussed just now, we said that RT is actually being spanned by T of beta. And what is beta? Beta is the basis. So every element of the basis, its transformation, its image under the linear transformation has to be found. Now we have got our basis. In this particular problem, your P2R is V and your M2 cross 2R is W. We need to find what happens with this particular elements. What are their images under the transformation? So 1 is definitely a polynomial. X is a polynomial. X square is a polynomial. 1 can also be expressed as linear combination of 1x and x square. So now what I'm going to do is that I'm going to substitute these on the right hand side. So we'll get, what will I get? Tell me. F of 1 minus f of 2 0.
So shouldn't you
Zero.
write T of f of 1?
No, I'm using this.
Yes, sir. I mean, shouldn't it be T of f of 1 instead of T1?
Fx is itself 1. It's a polynomial. Yeah, polynomial fx is 1 itself. Fx is 1. Next we are going to consider fx to be x. Then we are going to consider fx to be x square.
Okay, sir. Okay.
Now our polynomial, it's itself 1. Now you see that we want to find the image of 1 under this function. What is the image of 1 under this function? What is image of 2 under this function? What is image of 0 under this function? Bolo. What am I going to substitute here? What is the image? Remember, the function is this.
Sir, 0.
No, not 0.
Sir, I mean f1 minus f2 should be 0, right? If fx is equal to 1.
Just a minute. It is not. My pen is not again. Okay, fine. See what you are saying? F1 minus F2. What is F1? Tell me specifically. Tell me what is F1?
F1 is 1.
1. Yeah. F2 is.
Then f2 is also 1.
1. Yes. Now this way. 0, 0. What is F0?
1.
1. Okay. You are right, but I want you to be more specific, because others, if others are having any trouble, then they will understand. So the image is 0, 0, 0, 1, isn't it? This is the image of T1 under this transformation. Remember, this is my polynomial, and I am substituting in place of x, I am substituting 1 over here. In place of x, I am substituting 2. In place of x, I am substituting 0. So here f of 1, for this, f of 1 is 1, f of 2 is 1, f of 0 is 1 under this function. So we are substituting these members over here, and then we are saying that t of 1 comes out to be this. Now similarly, you find out what is t of x square, and then you find out what is t of first of all you find out t of x, and then you find t of x square. Now when you try to find out t of x, then remember this is my function fx equal to x. Okay, so we get, again you write f of 1 minus f of 2, 0, 0, f0. And remember, now at this stage I am considering this function. So what are the elements? F of 1 is 1,
0.
1 minus 2.
1 minus 2, 0, 0, 0, and 0. So we get minus 1, 0, 0, 0. This is the image of x under the transformation. Now we are going to find t of x square. When we want to find t of x square, remember this is my function. This is my function. So we write f of 1 minus f of 2, 0, 0, f of 0. Now what is f of 1? It is 1.
1.
F of
Minus
2,
4.
4, 0, 0, and
0,
0. Okay,
0.
so we get minus 3, 0, 0, 0. So this is the image. These are the three images of the elements of the basis elements 1, x, and x square under the transformation T, as defined in this particular formula. Now just try to recall the theorem that we discussed just now. In the theorem we said that this these elements, I mean RT, is actually span of T beta. Okay, and this means RT is equal to the span of these elements TV1, TV2, ... TVN. Now if I try to apply this rule over here, in our case, in our problem, RT will be span of T of 1, T of x, T of x square, according to this theorem. Now what is T of 1? T of 1 is 0, 0, 0, 1. So this is 0, 0, 0, 1. What is T of X? T of X is minus 1, 0, 0, 0. T of X is minus 1, 0, 0, 0. And T of X squared is minus 3, 0, 0. T of X squared is minus 3, 0, 0, 0. Okay. So this is my span. This is my span. This is my RT, which is actually means what? This means what? Any element of T can be expressed as linear combination of these elements 0, 0, 0, 0, 0, 0, 1, minus 1, 0, 0, minus 3, 0, 0, 0. Now here is a important point that you need to follow carefully. Previously, I said that beta is a basis. Beta is a basis, which implies that every element of beta is Li. The elements of beta are Li. Okay, not every element. The sentence is wrong. The elements of beta are Li. Elements of beta are Li. But T beta, we only know that it spans RT, but we do not know whether the elements of T beta are Li or not. Now you observe, what is my T beta here? My T beta in this particular case is 0, 0, 0, 1, minus 1, 0, 0, 0, minus 3, 0, 0, 0. Okay, this is my T beta. If you observe carefully, you will find that you look at these two members. You see that minus 3, 0, 0, 0, this particular member can be expressed as a linear combination of this. It is nothing but the scalar multiple of this. I mean, you can express minus 1, 0, we can express minus 3, 0, 0 as the scalar multiple of minus 1, 0, 0. So actually these two members are not Li. They are not Li, and therefore these three members are not Li. One is this is the scalar multiple of this. This is scalar multiple of this. So obviously we can say from this particular problem that T beta's member may not be linearly independent always, as it is coming out from this particular problem. Now suppose in this problem, if what I asked you in this particular problem, I asked you to find RT. Okay. Now suppose, now one definition then that I'm going to introduce over here. We know that if we have a basis, then number of elements, okay, I'm writing here clearly. If we have a basis, then number of elements present in the basis of V is what? Can you tell me? Number of elements present in the basis is what? What it is called? Number of elements present in the basis of the vector space. What we call it?
Dimensions.
Dimension of the vector space V. For example, as I discussed in the previous class, that 0, 1, 1, 0 as we say that 0, 1, 1, 0 is the basis of R2, and therefore R2 is two-dimensional. R2 is two-dimensional. We discussed this particular point in the previous class. Now remember that we have come across two particular idea. One idea is, in the previous class we discussed about kernel of T, which we actually denote by car T, and range of T, which we actually denote by RT. Okay, RT. Now remember, this car T is actually a subspace of the vector space. It is itself a vector space. RT is a subspace of a vector space, so it is itself a vector space. Now from this I'm introducing another definition. It's saying that the dimension of car T, if you want to find the dimension of car T, this is actually called nullity of T. It is known as nullity of T. And if you can find dimension of RT, it is called rank of T, rank of the linear transformation. The rank that we actually discussed with respect to matrix, this rank is same as that. Okay, because every matrix, you will later see that every matrix has a linear transformation. Every linear transformation has matrix representation. So whenever we find the rank of the matrix, actually we are finding the rank of the linear transformation, associated linear transformation. Whenever we find the rank of the linear transformation, that means you are finding the rank of the associated matrix. So basically they are same thing. This rank is the usual rank that we actually studied in matrix theory. So remember this definition: the dimension of car T is equal to nullity of T, and dimension of RT is rank of T. Okay, from here I'm going to find out the dimension of RT. So for this problem we want to check what is the dimension of RT. Now let us try to find it out. If I want to find dimension of RT in the given, for the given problem, actually we need to find a basis which spans the members of RT. Okay, we have got our spanning set. Actually, but in the spanning set there is a problem that the third member is actually the scalar multiple of the second member. So we cannot say that T beta is basis. It is not a basis, but what we can do, we can omit the third member. If you want to construct a basis out of it, if you want to construct a basis out of it, what we can do is that we can omit the third element and we can only write 0, 0, 0, 1, minus 1, 0, 0, 0. Why? Because it doesn't have any meaning whether we write minus 3, 0, 0 or not, because minus 3, 0, 0 can always be expressed as scalar multiple of minus 1, 0, 0. So actually the basis here is, if we talk about basis, then this basis here is this one is the basis, because it will also span the members of the vector space, and these are the linearly independent vectors. How many members are present in this particular basis? In this two. So this basis element, this basis has two elements, two members, and therefore dimension of RT or rank of T in this particular case is equal to 2. So here in examination you may find this type of problem where they will ask you, they can give you this particular problem, and they can give you this type of transformation, and they can ask you what is the basis of, they can ask you what is the basis of RT, or they can ask you what is the dimension of RT. They can ask you to find rank of T. Okay, understood? Now suppose, do you have any doubt regarding this point? Any issue?
Sir, when the question is to just find RT, then we should let that other element remain.
Yeah, if the question is just about finding RT, then your answer is up to this. You have to find span
sir.
of T beta. But if they ask you what is the dimension of RT, then you have to deal with this linearly independent part. Okay.
Yes.
Okay. Now, there is a very important theorem which is called rank nullity theorem. The theorem says, the theorem is very useful. The proof of the theorem is not required actually. Rank nullity theorem says that suppose we have two vector spaces V and W defined over a same field F. We are defining a transformation T from V to W. And suppose this transformation is linear transformation, remember. I'm talking about the linear transformation. And suppose the dimension of RT is being defined as rank of T as we know, and dimension of kernel of T is being defined as nullity of T, then this rank nullity theorem says that rank T plus nullity T will always give you dimension of V. This is called the rank nullity theorem. This is called the rank nullity theorem. Rank T plus nullity T will give you the dimension of the vector space V. Now suppose this theorem's proof is not actually required in our case. You can omit the proof. We'll just use it for the problem, for solving the problem. Now suppose if I ask you for the given problem, that means the problem that we have discussed, we have taken a lot of amount of time to discuss this given problem, because if you understand this problem, then you will be able to do the other problems also. So if I ask you here in this particular problem, what is the value of nullity of T in the previous problem, what will be your answer?
0.
Why? Justify.
Sir, because rank T and dimension of V are equal to 2.
Rank
So
T
2
is
plus
how
0
much? Yeah, rank T is how much?
2.
2.
2.
And nullity T we want to find out, isn't it? Nullity T.
Yes, sir.
And dimension of V is what?
2.
No. Think, and I'm making, just someone is calling me. I'm making a call and then I'm going to continue. Just a minute. Someone is calling. You think. Because just now,
No, sir,
we discussed that 1x square is the basis of art.
yes,
Basis
sir, it
of
will be 3.
Yeah, it will be 3. So this implies
Is 1.
nullity of T is equal to 1. Nullity of T is equal to 1. That means what? That means the dimension of car T is 1. Dimension of car T is 1. Kernel of T has one dimensional. So if in this particular problem you have any doubt, any other doubt regarding this problem, then you can ask me. Have you understood the problem? Because this problem is actually very important. Okay. I hope you are understanding. Then nobody is questioning. Then let me go to the next phase. The next phase, I'm going to give you a problem. Suppose let T colon P2R to P3R be a linear transformation defined by P2R is the set of all polynomials. So it contains the all polynomials of degree less than or equal to 2, and P3R contains all polynomials of degree less than or equal to 3. So here the transformation is defined as follows. T of fx is equal to 2 into f dash x plus 0 to x integration 0 to x 3 ft dt. This is the transformation. Your job is to find dimension of RT, find dimension of RT, and also find nullity of T. This is the problem. Now, tell me how to solve it. What you are going to do. You tell me and I'm going to write on the board. You are going to do this problem sequentially. As I said, first of all, when you are going to give me the reply to the given problem, you are going to give the reply in a sequential manner. Just don't give me the final answer. If you type in this particular problem in the internet, probably Stack Exchange will show you the solution or the answer. Okay, I don't want that. I want the dissection of the given problem. So stepwise, you tell me what we need to do.
First, we need to write the basis of P2R.
Yeah, okay, stop. Basis of P2R. Basis of P2R. Let us denote this by beta. And this is 1x squared.
X squared.
Okay, now tell me next.
So now we'll find T of 1, T of x, and T of x squared.
Okay, now we are going to find T of 1, T of x, and T of x squared. Step 2, we are going to find T of 1, T of x, T of x squared. Now, what are these values? Tell me. Let's talk about T of 1. How can I find? What is T of 1? When we say T of 1, when you talk about T of 1, that means you have chosen the function to be, 1, a polynomial 1. Fx is equal to 1. With respect to this, we are going to find T of 1. What will be the value?
Yes, sir, f dash x will be 0.
F dash x will be 0.
ddx of 1, say it in this manner, ddx of 1 plus 0 to x 3 into
0 to 1.
No, 0 to, not 0 to 1,
0
not
to x.
0 to x,
Yes.
0 to x, 3 of 1
Yes, sir, 0 to x, 3 into 1 dt.
dt. What is the value of this?
4x.
It will be 0 plus 3.
Bolo, what is the value of this? Not 4x.
3x.
3x. Okay, so T1 is equal to 3x. Now tell me what is the value of TX? TX.
Is f of t is equal to 1.
F of t equal to 1, obviously. The variable of integration is changing. This is the integrand. 3 into ft is the integrand. Ft is equal to 1. Limit is from 0 to x. Upper limit is variable. Because the image of this member has to be polynomial also, isn't it? So it is a
understood.
it is a first degree polynomial. It will definitely belong to P3R, because P3R is the set of polynomials having degree less than or equal to 3. Now what will be the image of Tx? It will be 2 into ddx of x, okay, plus 0 to x
3x
3t 3t dt.
3t dt.
Okay, now integrate and tell me what is the value.
2 plus 3x square by 2.
Okay, 4 what 4 plus
2 plus 3x square by 2.
x square by 2. Tell me what is the value of tx square, which will be 2 into ddx of x square plus 0 to x 3 into t square dt.
4x plus x cube.
4x plus x cube. Now all these polynomials, this one, this one, this one, all these polynomials, this is a first degree polynomial, second degree polynomial, cubic polynomial, all will belong to P3R. Therefore,
Yes.
therefore our RT is equal to span of, our RT is equal to span of these members, 3x, then 2 plus 3x square by 2, comma 4x plus x cube. Our RT is the member of this. First job is done. Second job, we want to check whether this is a basis or not. My T beta actually here is this set 3x plus 2 plus 3x square by 2 plus 4x plus x cube. Check whether whether T beta is basis of RT or not. Now to be a basis, it needs to be a spanning set. It is of course a spanning set. We have already found. We
Independent.
yeah, check. So check whether T beta is Li or not. So how can I do this? We'll select 3 scalars. We will select 3 scalars A, B, C from where? R, because P2R field is R, and we will write A into 3x plus B into 2 plus 3x square by 2 plus C into 4x plus x cube. And on the right hand side, what will I write? Follow. Linear combination. To check whether a vector is linearly independent, we need to take their linear combination a1 b1 a2 v2 plus dot 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 an vn should be equal to 0. And if it implies that a1 equal to 0, a2 equal to 0, an equal to 0, then we can say that here this is linearly independent. Now, but on the right hand side, what will I write?
0.
No. What is the 0 in P2 in P3R? What is the 0 in P3R? It is not just 0.
0 into x cube plus.
Yeah, 0 into x cube plus 0 into x
0
square
x square
plus 0
0x plus
into
1.
x.
0.
Yeah, plus 0.
Plus 0 into
Now equate all the coefficient. Equate all the coefficient and tell me whether A, B, C are 0 or not. Equate the like coefficients and tell me whether A, B, C are 0 or not. (3a) equal to 0. So A equal to 0. No, 3a plus 4c equal to 0. Okay, we will get from here 3a plus 4c is equal to 0. That is one equation. Another equation that we'll get is twice b, the constant, twice b is equal to 0. That is another equation. Then we will get
C equals to 0.
3b by 2, 3b by
Equals
2
to
equal to
0.
0 and c equal to
B equal.
c equal to 0. Isn't it? Am I
Yes,
right?
sir.
So,
Yes.
so A, B, C are all 0.
Yes, sir.
Yes, sir.
A equal to 0, B equal to 0, C equal to 0. And therefore, this set T beta is Li, linearly independent set. So this set T beta, this set 3x plus 2 plus 3x square by 2 plus 4x plus x cube is a basis of RT, and therefore dimension of RT is
3.
3. What will be the dimension of RT? Means rank of T.
Rank of T.
What will be the nullity of T? What will be nullity of T?
Sir, 1.
Nullity T plus rank T equal to dimension of B, isn't it?
Yes, sir.
What is dimension of B?
4.
Dimension of B. Dimension of B.
3.
3. So dimension of B is 3. Dimension
0.
of RT is 3. So nullity is T is 0. And there is a theorem in the book. It says that from here I'm writing the theorem in page number in the chapter of linear transformation. It says that if nullity of the transformation is 0, kernel of T contains only one element, and that is the 0 vector. Here it will be the 0 polynomial. It will contain 0 into x cube plus 0 into x square plus 0 into x plus 0. It is a theorem actually. If dimension of car-T is 0, then car-T contains only one element and it is the 0 vector. This completes your problem. This is the answer. We have less than 1 minute. Please join again once again for 5 minutes, and then I'm going to conclude my today's class. I just want to give the finishing touch.
So where did you find that the dimension of V is 3? Can you show it me once again?
Yeah, join again. I'm telling you.
Okay, sir.